Next up, we have Andrew, who is a fellow and also the Senior Director of Software Communities at ARM, and he's spent over 20 years working with open source. He's actively involved in a variety of different projects and communities and sits on a number of foundation boards, including FreeBSD, Rust, Zen, and Yocto. So he is the perfect person to tell us about unleashing the potential of ARM architecture. So everybody, could you please put your hands together for Andrew?
So, afternoon, everyone. Hopefully, you've recovered from your lunch. One thing I would like to ask first, before I get started, is could everyone just raise one arm? Doesn't matter right or left, I don't mind. Just everyone raise an arm. Thank you very much. Just my arm-powered glasses, making sure that they're working, that's all. Thanks for that. So as mentioned, I'm Andrew Wafaa. I head up our ARM's open source office, look after a wide variety of interactions with various software entities and communities around the world. I'm going to take you through how software developers will be able to unleash the full potential of the ARM architecture, which just happens to be one of the most pervasive computing architectures out there at the moment. So we want to make your lives much easier as software developers. And if you've worked in the ARM ecosystem for a while, you'll know that it never used to be quite easy, right? In the 32-bit space, it was always very painful and such like. So we understand and we've learned from the pain that we inflicted on software developers in the past. We want to try and improve on that now. And computing nowadays has got far more complex than it used to. You've got aspects where it's not just developing on hardware, for hardware, you've got Verilog, et cetera, and all those sort of pieces. You've actually got the various software applications running on top of those. Part of the complexity in modern software development now is that things are blending. Things like the cloud-native methodology is not purely for working in clouds like AWS, GCP, et cetera. It's being seen heavily utilized in automotive, in the IoT space, networking, et cetera. So making sure that those modern methodologies apply across the stack. And let's not forget, it's 2024. AI is now pretty much at every corner that you turn. And so the complexity of growth with AI is phenomenal. So we want to make sure that you have the various tools, libraries, et cetera, available to make the most out of those various components. So with all these challenges in mind, we absolutely are invested in software development. So I've got a few questions for you. Let's see if anybody has an idea as to what they are. Does anybody know how many ARM chips have been shipped to date-ish? I'll give you to within the nearest 10 billion. Any ideas? 280 billion ARM chips have been shipped to date worldwide. It's a fair-sized number. So next question then is, how many open source software developers does ARM have, right? Any ideas? 1,000. Over 1,000 dedicated open source engineers. We've got a load more software engineers as well, but these are purely people working on open source. things like Kubernetes, the various languages, whether it be Golang, Rust, etc. So we've got 1,000 engineers. How many software engineers in total does ARM have, right? We're an IP, a processor IP design company. How many software developers do we have in total? 40% of ARM's global workforce are focused on software, right? ARM very much is not a hardware company. At the end of the day, without software, CPUs, GPUs, etc., it's just expensive sand, right? So you need software to make the best out of that hardware. So, as I mentioned, software is pivotal to what ARM does. It absolutely drives our innovation as an IP design house. And because we're relentlessly focused on providing the very best support to the millions of software developers out there in the world that are building for ARM on ARM, we ensure that you have access to the most performance, or you've got access to the performance tooling and libraries, as well as ensuring that the various communities that you're engaged in are well supported and have all that they need. And we're also making huge investments in the CI/CD space, ensuring that, you know, working with people like GitHub and others, that they have full support for the CI/CD stacks that you want to leverage. And a lot of this is achieved through various development toolboxes that harness the various aspects of the ARM architecture. So let me just go through a few of these tools that are available to you to enable you to actually leverage the best out of our architecture. First one is Kleidi. So ARM Kleidi is our broad program of software for accelerating artificial intelligence and machine learning. We started with the ARM Kleidi libraries for various, or for the most popular AI frameworks. And this enables a lot of our developers to unlock the performance required and the capabilities desired using ARM CPU for inference. For AI, the CPU is critical. This is where the majority of the inference actually happens. It's not actually on GPU. The bulk of your inference happens on CPU. And this enables us to actually enable the best in AI, whether it be from cloud all the way down to small edge devices, home gateways, etc. It makes CPU the easiest path for software developers to actually target AI workloads. It's what's used currently now. It's what's available to everyone. And Kleidi libraries that feature Kleidi AI are targeted at the large majority of AI workloads. And we also have Kleidi CV, the best in class for computer vision workloads. So, as I mentioned, Kleidi AI is a collection of highly optimized AI kernels that deliver high performance for use cases, things like generative AI. And we're already working with a lot of the key AI frameworks, including MediaPipe, so via X and MPAC, Llama CPP, PyTorch via Executorch, TensorFlow Lite via X and MPAC again, to integrate Kleidi AI. This accelerates the development process and unlocks the highest possible performance, so developers can create the best AI experience that they want. The integration of Kleidi AI is leading to significant performance improvements for Gen AI workloads. And it also accelerates the time to first token for things like Meta Llama 3 and Microsoft's Phi 3. Large language models are increased by about 190% for time to first token. And it ensures that engineering teams are able to actually work much quicker and get up to speed much quicker through leveraging the CLIDE libraries. Through CLIDE AI integration with MediaPipe, provides the support for likes of Gemma, OpenLLM, running on mobile. And there's a 25% improvement for time to first token for Gemma 2B on the Google Pixel 8 Pro. So integrating CLIDE CV accelerates the computer vision pipelines that are used for many of the camera use cases and has led to significant performance improvements. So we've worked very closely with the OpenCV community, and we've managed to create an uplift of about 75% for a variety of image processing tasks. This has been a huge collaboration, and a lot of our software engagement is in the form of collaborative work. So we can actually help educate the community so that they can actually be far more self-sufficient. Another aspect of our toolbox is ARM Performance Studio. So we started off with ARM Mobile Studio, and we iterated upon that, and we started to see ways that we can actually leverage Performance Studio and leverage Mobile Studio to actually benefit a wider set of developers, and so we created Performance Studio out of that. A lot of these tooling, Performance Studio is a collection of analysis tools, and it now supports a wide range of workloads from platforms and devices far beyond mobile. It supports all the new Neoverse server CPUs, as well as fully supporting Linux platforms. Also, as part of Performance Studio, we've managed to add ARM Frame Advisor, and so this makes those that work in the graphics space able to actually profile and optimize much easier, and makes it much more accessible for people to actually do that. As ARM is pervasive, we are across from sensors all the way through to the cloud to supercompute. Automotive is a key part of our target space. And so to enable faster time to market, we've got something called virtual platforms and ARM virtual hardware. And so for automotive and IT markets, these really do help people get to market very quickly. They allow a lot of our partners to actually evaluate the IP that they're looking at creating. Creating CPUs and a lot of processors takes a lot of time from initial acquisition of the IP, can be up to 2 years. And so by leveraging AVH here, it actually enables people to actually test their software much quicker in a much more realistic environment as early as possible. So when the physical devices actually land in product, they know the software is going to work fine. And so this kind of matters to a lot of software developers because you won't need to wait for the actual physical silicon, as I said. You can actually start testing it, validate. There are going to be some corner cases when real hardware comes out, but for the most part, you're going to be able to get up and running very quickly. And so a lot of this is supported by ISA parity, and now that exists right the way through from cloud, like I say, all the way down to edge devices. So another part of our development toolbox is our wide range of open source investments. This is an area that's very near and dear to my heart. And we contribute to well over 1,200 projects in all verticals. And things like long-established partnerships that we've had with Lenaro, who have been around for now, 12, almost 15 years, who are focused on providing the open source community with access to the broadest range of software tools available to them. One notable open source project is the Windows working group within Lenaro that's actually working to enable better support for, believe it or not, Linux on these devices. But working through collaboration with Microsoft and Lenaro, enabling people like Bazel, CMake, the LLVM project, OpenVPN, Python, Qt, etc., to actually better support the architecture. And again, working on enabling CI/CD on the Windows platform for the ARM architecture as well. We work very closely with, let's say, a lot of the language and libraries. And so we've done huge investments in Go and Rust and Java space. And so they now just work out of the box. So depending on what your preferred language is, you're going to be able to get up and running without any issue whatsoever. We've also got CMSys Pack, and that there, put my teeth back in. That enables our community for a much cleaner and simpler structure for deploying in the IoT space. And last but not least, we have RAN acceleration. In the network space, having an open RAN library that is as performant as possible has been a key market in that vertical. So moving away from our toolbox, there are a number of leading global initiatives that we are investing heavily in to enable our developers and developers as a whole better access and better integration with the ARM architecture. So we've got our ARM developer program, and if you swing by booth 59 or 56 here in Hall A, you'll be able to get far more details on that from many of our actual members, ARM experts, as well as ambassadors that are there. So I'd like to kind of close out and invite you to help build the future of computing. We are fully committed to the software ecosystem. We want to hear from software developers. We don't we don't actually participate in all the projects, so we don't understand and know of all the different pain points that you're going to have. So please do participate in the developer program. Let us know what works, what doesn't work, what are pain points for you, what are features you would like to see, what are the IDEs you're using, what are the various libraries that are core to your projects. We want to ensure that we equip you with the latest and greatest tooling. We've made a start. We are in this together with you as software developers. We want to hear what you need, what you want, how can we help you. Let us build out that toolbox, make it far more applicable for you, and make it easier for you to actually just get up and running. And ultimately, at the end of the day, you'll be able to write for the ARM architecture, and regardless of whether you are on the edge, in the cloud, supercompute, client devices, phones, tablets, glasses, we'll be able to get your software running as quickly as possible. And with that, I'd just like to say thank you very much, and any questions?
Amazing. Thank you so much, Andrew. So just to remind you all, we have an app. You can ask your questions in the app on the Questions tab if you click through on Andrew's talk. So at the moment, we have just one question for you, which I think is actually quite an important question. So you mentioned 280 billion chips sold. Is that a US billion, or is that a rest of the world billion? So are we talking 1,000 million or a million million?
So ARM is a UK company. So it's a proper billion.
A real billion. Excellent. Okay. Thank you so much.
His Majesty's billions.
Okay, and let's see if any more questions have come through. If not, so ARM is pretty ubiquitous these days. Can you tell us anything about ARM's plans for the future, for the next 5 years, 10 years?
Outside of world domination, I think compute, especially in the AI age, is going to be harder and harder to sustain. The resource requirements on a lot of the AI platforms is just getting somewhat ridiculous. We've recognized that, and we're trying to leverage our expertise from the mobile space, where power is critical, use as little as possible, et cetera, and whatnot. And we're looking at ways of how can we actually enable the AI space to be far more power efficient. How can you do your compute that you need, yet draw a reasonable amount of energy and not worry about it? So that we are working towards a more sustainable compute space.
Excellent, very cool. And are you, I mean, your role, so obviously you're working with hardware. Is your background hardware, software?
I'm very much a software guy. I don't do hardware at all, other than break it. That's the extent of my hardware interaction.
Excellent, okay, that's very cool. So we have no further questions, but you said you're at a booth. Which booth?
Just in the corner, I believe it's 59, Hall A. So please swing by.
Excellent. So you can catch Andrew there. Thank you so much for listening. We'll see you back here in 10 minutes.
Yep.